All right, in this video, we're going to be talking about the Mach 3 review. So let's go and get started. All right, first thing you have is what appears to be a schedule of math classes at Archer High, and we have John wanting to take a couple of classes, or he's wanting to at least try. All right, so first thing we're going to do is take all the information here, and we need to put it there. All right, so Audrey 2, 3, 5, 6. Ford is 2, 3, 4, 5, 6. Aikens 1, 4, 5, 6. Jacobazzi 1, 2, 4, 6. All right, there we go. Wow. 1, 2, 4, 6. 1, 2, 4, X. Okay, so we're talking about probability. Now, of course, we've talked about this quite a lot this unit. And so remember to find the percentage. It's always what do you want divided by the total. All right. So what is the probability that John will take a math class during second period? Well, let's see. We're focusing in on second period. So those are 3. All right. So what I want is second period math classes, and I'm going to divide that by the total number of classes. So I'm going to add up all my X's here, which I believe is 17. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. All right, which 317. So let's go ahead and convert that to a decimal or a percentage, which rounds to 18%. All right, there we go. Let's clean that up and answer the next question. All right, what is probability that if John has a morning class, he will have Miss Aikens? All right, so this is where things get a little more challenging because we are only focusing in on morning classes. All right, so everything in the afternoon we don't care about. So that means the total changes a little bit. So what is probability that John has a morning class? He will have Miss Aikens. So Miss Aikens only teaches one class out of 1, 2, 3, 4, 5, 6, 7. 7 class offerings, because there's only 7 classes that are offered in the morning, which will be 14%. There we go. All right, let's look at question number 3. What's the probability that John will get a math class in the afternoon? All right, so the afternoon, we're just looking for afternoon classes, so I'm just going to count up all. Try that again. There we go. Hold on. There it is. So I'm going to count up all the afternoon classes. All right, so count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 afternoon classes divided by the whole thing. So we didn't specify the total, so it always defaults back to 17 if it doesn't give you a modified schedule or modified total, which rounds to about 59%. All right. Okay, so let's clean that up and work on our next one here. All right, question number 4. What is the probability that John will get Mr. Jacobazzi as a math teacher? So it's not specifying in the morning or afternoon, so we're just talking about Mr. Jacobazzi. So that means he could get first period, second period, Jacobazzi, fourth or fifth. That's a total of 4. So 4 out of 17.
Okay, now I get it.
There we go. Which rounds to about 24%. All right. Remember, if it doesn't specify a particular total, it defaults back to the grand total, which is 17 in this example. All right, what is the probability that John, here we go, has an afternoon class, he will have Miss Alter. All right, so because of the fact that it talks about an afternoon class, that means all of the morning classes will not be used. All right, so make sure you read the question correctly. All right, so we're talking about an afternoon class, which means all of the morning classes, we don't care about that. The morning class is just the afternoon. Let me rewrite that 24% erased. So what's probability John will have Mrs. Audrey? So let's see, Miss Audrey teaches it 2 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 out of 10. I'm doing this very quickly, so I'm hoping I'm not messing up here, which gives you 20%. Like so. What is the probability that John will have Coach Ford? All right, so again, we're not doing any type of in the afternoon. We're not doing any type of just in the morning, so that means we default back to 17 as our total. So Coach Ford, 1, 2, 3, 4, 5. That is 5 out of 17, which is going to give you 5 divided by 17 gives you 29%. There we go. And that's it. All right. All right. Question number 7. Let's go ahead and find the missing probabilities of the tree diagram. All right. So there's a lot of things that we're going to have to find. Okay. So I know that we do have a whole bunch of things that we got to find, but I'm just going to find everything. First off, remember every time that the tree forks, it equals 100%. So that means here equals 100%, this equals 100%, that equals 100%, that equals 100%. All right. So let's look at the 0.28. So 0.28 going to D, which would lead to 0.72 going to E. If you look at Z, it's 0.63 going to E. Z would be 0.37, which I think is one of our answers, 0.37. Okay? All right, now, this is where things get into a little more trouble because we now have to start doing some multiplying and dividing. So first thing I'm going to find is this guy right here. All right? Now, if you remember, and I'll do a little more drawing here, this branch times this branch equals that. All right? Remember how I kind of label this, very elementary style. This is my end number. This is what I know. This is what I don't know. But I do, if you do remember, if you take what you don't know and times it by what you do know, that equals your end number. So to find what I don't know, I'm going to take my end number, divide it by what I know. So off to the side here, 0.0532 divided by 0.28. I believe that's going to be 0.19. So this here becomes 0.19. Okay? Now, I don't know what x is, and there's not enough information to find x yet, but this is my next thing I'm going to find. I'm going to start rather than putting x's. I'm putting too many x's on there. All right? So watch what I highlight. My little star times 0.37 gives me 0.0703. All right? So remember that the 0.0703, this is my end number. This is what I know. That's what I don't know. So I'm going to take the end number, 0.07, off to the side here, divide it by 0.37, and I get 0.19. All right. Now, remember what we started with. These three numbers add up to 100%. So to find x, very simply, I'm just going to take 1 and subtract it by 0.19 minus 0.19. And I did not do it correctly, minus 0.19. And I get 0.62, which is for x, so 0.62. Now, to find w, finding w is super easy because I already know the branches. All right, so let's see if I can do another highlighter, and it actually works. So this branch times that branch gives me w. So very simply, I'm going to multiply the two branches. Remember, whenever you're working with tree diagrams, when you're working to the end number, you just multiply your branches to get your end number. So w is equal to 0.1197. And then lastly, to find y is 0.19 times 0.72 gives me y. So the 0.19 branch times the 0.72 branch will give me y, which is 0.1368. There we go. Okay, question number 8 and 10. Let's get started. What is the probability that someone chose A for their first choice and then E as their second choice? All right. So let's see it. So A is their first choice is a 10% chance, and E is their next choice, which is a 20% chance. So very simply, I'm just going to multiply these two. So 0.10 times 0.20 gives me, I believe that ends up being 2%. Awesome, 2%. All right, now this is where things change because if you notice question number 8, you're giving me a percentage as your final answer. Here you're giving me people. So you do have to find the percentage, but then you're going to multiply it by the people. All right, so let's see what we have going on. So how many people chose B as their first choice? All right, so in this particular example, we're actually not going through the entire tree. We're just looking at the first branch. So B as their first choice, which is 60%. So 60% of the people will choose B. So 0.60 will be my percentage, and then the people is 1,200. So 0.60 times 1,200, 0.6 times 1,200 gives me 720 people will choose B. All right, question number 10, same exact thing, except now you're working through the tree a couple times. If 2,000 people were involved in the tree, how many people chose C as their first and D as their second? All right, so C is their first, is 30%. D is their second, is 60%. So I got to multiply these two together. So 0.30 times 0.60. I believe this is going to be 18%. And then I'm going to times it by 2,000 people. And you get 360 people that will choose C and then D, that combination. All right. Okay. For question number 11 and 12, we're dealing with an area model that actually has its own measurements. So we have to use the measurements as written. Okay. So we're going to have to do a little bit of work here. Okay. So first off, the entire height is 15, which means each row would have a height of 15, of 5. Okay? Now, from here all the way to there is 24 because it's 12 and 12. All right? So, that means if the whole thing is 24 units long, that means these little nodes will be 6, 6, 6, 6, and these little very bottom ones would be 3, 3, 3, 3, 3, 3, 3, and 3. So we have the width, we have the height for each rectangle. So now we have to multiply to find the area. All right, so the area, that would be 15, because 3 times 5, 15, 15, 15, 15, 15. This would be 30, 30, 30, 30, and then that will be 60, and that will be 60. Okay? Now, if you want to preemptively add all the pieces up, I believe it ends up being 360. If you added all the pieces up. Yeah. All right. So, again, preemptively add all the pieces up. All right. Now, here we go. If 500 people were surveyed, how many people chose no? All right. So, we're dealing with no. So, let's go ahead and find all of our no's. That's a no. These two are no's. Nope, that's a no. 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 That's a no. Well, actually, that's a no. All right. So we're going to add up all that is yellow. So that's a 16. That's a 90. That's 1, 2, 3, 4. What'd you end up getting?
210.
I got 210, yes. And you got 210, we're good. So 210 divided by the whole shebang, 360, which gives you like 0.583333, never stops. But then it's asking for people, so I'm going to take that and just multiply it by 500. So that means I'm going to round to the nearest whole. 292 people said no. What is the probability that someone says yes? All right. So if someone says yes, it's asking for the probability, so that means your answer is going to be in the form of a percentage. You add up all of the non-highlighted stuff, which I think gives you 150. So 150 divided by the whole thing, which is 360. Now, depending on how observant you are, you could have used some previous answer stuff. I'm going to round this to 42%. All right. Now, question number 13, another area model. All right. In this case, we're not given dimensions, and it does not look like bricks, so we're just going to kind of add here. So let's see, that's going to be a 2, 2. That will make that a 4. Make sure whatever number you use, guys, it is proportionate to the rectangle. So, like, for example, if these two are 4s, don't make that a 6. That'd be incorrect. All right. Ooh, all that erased. 4, 4, that would become an 8, that would become an 8, and that would become a 16. All right. What's probability of winning a rabbit? Well, I'm going to go ahead and do the whole, I'm going to go ahead and add everything up just so I can, because I know I'm going to be doing that. I believe it ends up being 64, so the whole thing adds up to 64. I'll probably be needing that later. We're trying to win a rabbit, so all my highlighted will be our rabbits. Rabbit. All right, so everything that's highlighted represents a rabbit, so that's 16 plus 36. So 36 divided by 64, we're looking, you got 60, 60% or 60 total?
60.
So when you divide it all out, we're going to go ahead and round 56%. There we go. All right. Now, question number 14. Now, remember what I said yesterday, guys, and that is make sure you read the question correctly because sometimes you're going to give me a percentage when you should give me a number and vice versa. If 200 people play the game, how many people will not win a rabbit? Now, depending on how observant you are, you can easily say, well, if 56 win a rabbit, then 44% will not win a rabbit. You can do that, and that would be accurate. But if you want to do it the old-fashioned way, you can just go back into your area model and just add up everything that does not have a rabbit. So all my non-rabbit numbers and squares I'll be adding. So when I add all that stuff up, I think it ends up being 28. That's awesome. Thank you. So it ends up being 28. We're going to divide that by the whole thing, 64. And then actually, to save time, what you could do is just do 28 divided by 64 in parentheses and then just hit times 200.
Got 86.
Is that what you got? I got 88. 88 people will not win a rabbit. All right, question number 15. I think this is it. Okay. All right. Remember question number 15? We have 4 pieces to the model. And I'm just drawing arrows so you can see what works where. Pizza only right there. So you're going to find out each dimension based off of everything and just apply it to the appropriate thing. All right. It says 680 people. So 680 people at the end of everything will add up to everything in this area or area in the Venn diagram. So let's go ahead and get some dimensions here. Starting with pizza only. All right. That's a 70. That will be a 30. That'd be a 70. Remember, it's a mirror image on top bottom. If you look at the right-hand side, it goes up to 40. That will be a 60. So 40, 60. Multiply everything out to go ahead and get our areas here, 2,800, 1,200, 1,800, and then 4,200. All right. Now, if you add everything up, the whole model ends up being 10,000. All right, we're going to need that. So first thing I'm going to do, eeny, meeny, miny, I'm going to do the neither. All right. So if you notice, the neither is 1,200. So I got to convert that to a percentage. So I'm going to do 1,200 divided by the total, which is 10,000, which gives me 12%. Now, I don't know if you guys can kind of work with numbers here, but whatever the first 2 numbers are is pretty much going to be the percentage. That's kind of a shortcut. All right, so 12% times the number of people that played the game or took the survey. So 680 times 0.12. I'm going to round here, and that's going to be 82. There we go. All right, eeny, meeny, miny, we're going to do the both. All right, so off to the side, we're going to do the both. So 1,800, when you divide that by 10,000, again, shortcut, you get 18%, and then you're going to times that. Running out of room here, 680. That's a 680. 680 times 0.18. Both ends up being, we're going to round here, 122. All right. All right, so hamburger only, we'll do this in purple here, is 4,200. We've done this enough to, I bet you know what 4,200 converted to a decimal would be. There you go, which is 42%. Times that by 6,800. Sorry. 680. So 680 times 0.42, which gives you, we're going to round here. It looks like hamburger only is going to be 286. 286. Okay. All right. And then just for good measure, pizza only. All right. So I'm gonna go ahead and just do this with my calculator. I'm not even going to put it on here. I'm not going to say waste time here. So that'll be 28%. So 680 times 0.28 gives me 190. All right, rounded. All right, that is the that is the review for the mock. So hopefully that worked out for you. Let me know if you have any questions.